In our last video, we did section 2.1, which was learning about the tangent ratio, and we used the tangent ratio to find an angle. This time we're going to use the tangent ratio to find an unknown length in a triangle. Again, this only applies to right triangles. So the question here is to determine the length of side xy to the nearest tenth of a centimeter. So I'm going to write tan z, because z is the angle that we know about. Okay, so tan z equals opposite over adjacent, because that's what we always write for tangent, adjacent tan. Okay, and then tangent of z is 70 degrees, so we're going to plug in our numbers now. Tan z equals opposite, which we can call xy, because this is the opposite here, divided by the adjacent, which is 5.0. And then we need to do a little algebra, so we need to multiply this side by 5.0 and multiply this side by 5.0. These ones cancel out, and we are left with 5.0 times tan 70 degrees equals xy. Now, just a word about notation. We don't need to put a times in between the 5.0 and the tan. The multiplication is implied there, just like when we put a number beside a variable. Okay, and then we take out our calculator, and our calculator tells us that xy equals 13.737, which means that to the nearest tenth of a centimeter, the length of xy is 13.7 centimeters. Does that look reasonable? If this is 5, yeah, 13 seems reasonable for 5. That was 5. Okay, next example. Determining the length of a side adjacent to a given angle. This one's a little bit more complicated algebraically, but the process the idea is the same. So this time we are looking for the length of xv. We're looking for this side here, and this is now the adjacent side. And this is the opposite side of the angle that we know, which is v. So tan v equals opposite over adjacent. So tangent of 42 degrees equals 7.2 over xv. Oops, xv. So we need to multiply. We need to get rid of the fraction first. So we're going to multiply this side by xv and multiply this side by xv. And these xv's cancel out, and we are left with xv tan 42 equals 7.2. And we want the xv by itself, so we're going to divide this side by tan 42. We're going to divide this side by tan 42. And we are left with xv equals 7.2 divided by tan 42. So we plug that into our calculator, and we get xv equals 7.996. So to the nearest tenth of a centimeter, xv is 8.0 centimeters. Looks reasonable. It's a little bit longer than the other side. It's reasonable. Okay, on to the next page. Now a little notation about notation. The convention is that uppercase letters are used for the vertices. I'm not sure how to spell that. Vertices, I think that's right. And the sides are labeled with lowercase letters. And in fact, it's the lowercase letter of the opposite vertex. So if this vertex is A, the side opposite is A. This vertex is B, the side opposite is a lowercase b. And we have a C in this corner, this vertex, the side opposite, is a lowercase c. Okay? It's less confusing than saying side AC or side BC or XZ or whatever. Okay, third example. Using the tangent to solve an indirect. Oh, I can't fix that on this. Solve an indirect measurement problem. Typo in my notes. At a horizontal distance of 200 meters from the base of an observation tower, the angle between the ground and the line of sight to the top of the tower is 8 degrees. So this distance here on this drawing is 200 meters. And this angle is 8 degrees. How tall is the tower? So we're looking for the height of the tower. Now I'm going to say don't use h if you can help it, because h is for hypotenuse. So let's use t for tall, or t for tower. Now this diagram is not to scale, so our number is not going to look like it's not going to work for us to ask if that's reasonable. Okay, so I'm going to introduce another piece of notation here, which is when you're writing your tan, I always go tan theta equals opposite over adjacent. Theta, this is the Greek letter theta, and think of it as a variable that's used for angles. It's just tangent of any angle is opposite over adjacent. So I'm just going to put that in, and then I don't need to necessarily come up with a variable for it right now. So we have tan, we're going to sub in our numbers that we have now. So we have tan of 8 degrees equals the opposite the angle is t, and the adjacent is 200. Use some algebra here. We're going to multiply this by 200. That's going to cancel out. We're going to multiply this side by 200. And we're going to get 200 tan 8 equals t. And we'll use our calculator to find out that t equals 28.108. It asked us to the nearest meter. So the tower is 28 meters tall. And that's it for section 2.2.